After the topic of monodentate ligand, let's come to the next type of ligand, that is bidentate ligands. Bidentate ligands have two donor atoms. For example, the bipyridine, which is written as BPY, or this, or this bipyridine can be represented in these three forms in coordination compounds. So the structure is, here the two donor centers are available in this ligand. So it can connect to the metal ion or central metal atom via these two nitrogen atoms. As this ligand has two donor atoms, so this ligand is called bidentate. Some another example, ethylene diamine, which is represented as En. The structure is, again here we can see that there are two donor atoms available in ethylene diamine ligand, which is this nitrogen center and this nitrogen. These two nitrogens can donate electron to the metal ion and forms metal ligand bond. Some other examples, propylene diamine. It is represented as Pn. So the structure is, here also there are two nitrogen donor atoms. Some other examples are trimethylene diamine, which is represented as Tn. The structure is, here also there are two nitrogen atoms which can donate electrons to the metal ion. One important point is that the above two ligands, that is propylene diamine and trimethylene diamine, can show ligand isomerism. Please note this point, that is above these two ligands can show ligand isomerism. Some other examples of bidentate ligands are Bn, butylene diamine. The structure is, then oxalato. All of these bidentate ligands are very important in coordination compounds in the naming process and in the later detailed analysis or detailed study of coordination compounds. So next is oxalato, which is represented as OX, or it is also represented as OX2 minus, as it has two negative charges on it. This is a very common bidentate ligand. So here it donates electrons via these two oxygen atoms. Then we have glycinato. It is represented as Gly or Gly minus. The important structure is, so it donates electron to the metal via this oxygen. So next important ligand is, this is represented as DPPE. The name is 1,2-bis diphenyl phosphinoethane. Okay, after that we have tridentate ligand. As we can uh, as we can have the idea about this ligand, that it has three donor atoms. Some examples are diene, it is the donor center. So here there are three donor centers or donor atoms in this diene. The complete name is diethylene triamine. So there are many tridentate ligands. After that we have tetradentate ligand also. Obviously it has four donor atoms. So I am not explaining more about these ligands because it is for the people who have already completed all these subjects um, in their educational career, and after some advanced level we are going for some advanced level. So it is also a very basic part of this coordination compounds, but later we will go step by step into the advanced level. So I'm basically touching all these uh, basic introductory part of coordination compounds. So first part is ligand, and I hope everybody know about the nomenclature of organic chemistry and all. So then we have tetradentate ligand. It has four donor atoms. Obviously we have pentadentate, hexadentate, and combining all these are all called polydentate ligand. So some important points about EDTA, which is a hexadentate ligand, is that it is a very good chelating ligand. That is, it can form chelating compound with the metal, so that it is being used worldwide for the titration and in removal of metal poisoning. So to remove a metal, we can use EDTA because it forms a very stable chelating compound with the metal ion. And the structure is this. This is the full name is ethylene diamine tetraacetate. O is added here because it is a ligand. As we all know that in coordination compounds, ligand's name ends with O. 1, 2, 3, 4, 5, 6. It has 6 donor centers, so that's why it is a hexadentate ligand. Hexadentate ligand. So next classification of ligands is on the basis of their bonding behavior. So number one is ambidentate ligand. It is a monodentate ligand which have more than one kind of potential donor atoms. It is basically a monodentate ligand which has more than one kind of potential donor atoms, but at a particular time only one of them get attached to the metal. So it is basically a ligand which has two potential donor atoms, but at one particular time only one of them get attached to the metal. So it is basically a monodentate ligand which has two donor sites or more than one donor sites. For example, so these three ligands are the example of ambidentate ligand. Here the donor atoms, potential donor atoms are carbon, nitrogen, but at a particular time it will only donate via only one atom. Similarly, in this case, the carbon and oxygen, here in this case, sulfur and nitrogen, both can donate, but at a particular time, only one will donate. One important point about carbon monoxide ligand is that carbon monoxide ligand can form metal ligand bond via this carbon atom, and also it can form bond with two metal ion like this, but it cannot form a metal ligand bond via oxygen because carbon and oxygen have large electronegativity difference. That is, the electronegativity difference of carbon and oxygen is very large. But when we compare this carbon monoxide with CN minus ligand, uh, the electronegativity difference value of carbon and nitrogen is comparatively small. So it can form bond via carbon, either via carbon or nitrogen. But in case of carbon monoxide, this doesn't happen. So always remember this point.